Dear learners, a very warm welcome in the MOOCs of Power Generation Technologies. In this module, we are going to discuss about diesel power generation plant. I am Dr. Shweta Tripathi, Assistant Professor in Mechanical Engineering from School of Engineering and Technology, Indira Gandhi National Open University, New Delhi. After going through this module, you will be able to understand about diesel engine power plant. You will be able to explain fuel injection system and its functions and how diesel engine works. In a diesel power station, if you have ever seen, diesel engine is used as the prime mover. If you have not been to the diesel power station, still you might have seen the diesel generators in your homes or in any occasional events, etc. In this kind of power plants or diesel generators, the diesel burns or it is combusted inside the engine, and the products of this combustion act as the working fluid to produce mechanical energy. As we know that in case of diesel engine, generally the fuel is injected inside the combustion chamber and a very fine droplet of this diesel is injected there, and due to its auto ignition temperature, the combustion takes place and then the combustion occurs. The diesel engine drives alternator which converts generally mechanical energy into electrical energy. So as the generation cost for this kind of power plant is considerable due to high price of diesel, therefore such power plants are only used to produce small amount of power. Although when we compare these power plants with the steam power plants or hydroelectric power plants, what happens? Actually, when we have to generate bulk power at cheaper cost, we prefer steam power plants or hydroelectric power plant. But diesel power stations are also finding their places when the demand of power is less or sufficient quantity of coal and water is not available and the transportation facilities are inadequate. In spite of these points or in spite of these things, we can also say that diesel power plants are also used as standby sets for continuity of supply to important points such as hospitals, radio stations, cinema houses and telephone exchanges. Now if we talk about the advantages of this kind of power plant, that is diesel based power plant, then we can say that the design and layout of these power plants are very simple. And as you have seen that the diesel set, DG set or generators, so you might have seen that they occupy very less space in comparison to other power plant. So it occupies less space because the number and sizes of various auxiliaries is small. We can locate it to any place and it can be started quickly because it can pick up load in very short time, and moreover they do not have any standby losses also. If we talk about the quantity of water that is required for cooling in diesel power plants, the quantity required is very less. And if we see the economic considerations or the economics in terms of capital cost, so the overall cost is much less than that of a steam power station for similar capacity because the capital cost is very less for diesel engine power plants. If we talk about the efficiency of the plant, so this kind of plants have higher thermal efficiency than that of a steam power station, because in a steam power station we have various components, and more the components will be, more will be the losses, and so the efficiency will be, overall efficiency will be reduced. Whereas in diesel, in the case of diesel engine or diesel power plants, the parts or components are less. So when we convert energy, the conversion efficiency is higher. Why? Because in diesel power plant we are only taking the engine and from engine we are getting mechanical energy and that is converted into the electrical directly. But when we go for the steam turbine or a steam power plant, first steam is generated, then production of steam is there, then from steam we are going to move the turbine, then it will be condensed and then it will be converted into the electricity. So there are more number of plants, so at every step there will be some losses in terms of mechanical power or electrical power. So the losses will be more at each and every step and hence the efficiency will be down. Now the limitations, why diesel power plants are not that much used. First thing is that the operating cost, the fuel like diesel is very costly, and in the country like India where we are getting diesel from other countries, it will be really high. So that is one of the disadvantage. Then this plant doesn't work satisfactorily under overload condition and also for the longer period. So it is also a major limitation of this kind of power plants. Then for only small power generation we could use this kind of plant, and the cost of lubrication is also high because there are many parts there where reciprocating motion is there. So when the movement of the parts are there, we have to do lubrication to avoid frictional things. So the cost of lubrication is also high. When we talk about the maintenance, we all know that the maintenance cost for diesel engines is very high, so for that will be applicable for the diesel based power plant also. Now what are the essential elements of a diesel power plant? So the first thing that comes to our mind is fuel supply system, how we are going to supply the fuel. So generally if we talk about the power plants, it consists of a storage tank, then there will be a strainer so that the fuel will be filtered, and a fuel transfer pump will be there. The fuel oil that is supplied at the plant site is by rail transport or by road transport, and then this oil is stored in the storage tank, and from this storage tank oil is pumped to smaller tanks which are known as all day tank at daily or short intervals depending upon the fuel consumption. Whatever the fuel consumption is in the regular basis, accordingly we have to keep a smaller all day tank, and then we will transfer the required amount of oil from storage tank to the all day tanks. And from this tank fuel oil is passed through strainers, so that in case if there are some suspended impurities etc. in the fuel oil, then it will be strained out. So it will be passed through the strainers to filter, and then this clean oil is injected into the engine by a fuel injection pump. Now air intake system, and this system supplies necessary air to the engine for the combustion of a fuel. Generally it consists of a pipe for the supply of fresh air to the engine manifold, and some filters are provided there so that the dust particle should not come with the fresh air. So filters will remove dust particles from the air, and because these dust particles may act as an abrasive in the engine cylinder. So as diesel engine requires close tolerances to achieve its compression ratio, so we have to supply adequate amount of air there. As most of the diesel engines are either turbocharged or supercharged, so the air that is entering from the engine or from the intake manifold to the engine, it must be clean, it should be free of debris, and it should be as cool as possible. Sometimes we use the exhaust gases also so that the NOx emission could be reduced, but at that time also two kind of exhaust gas recirculation processes are there. So better is that cool air should be there. If we are circulating exhaust gas, then also there is a cutoff so that the temperature of the air should not be too much. Then To improve a turbocharged or supercharged engine's efficiency, the compressed air must be cooled after being compressed. So, the air intake system is designed to perform these tasks, and this air intake system is generally of two types, wet or dry. So, in wet filter intake system, the air is sucked or bubbled through a housing that holds a bath of oil such that the dirt in the air is removed by the oil in the filter. The air then flows through a screen type material to ensure any entrained oil is removed from the air or not. Then comes the dry filter intake system. In a dry filter system, paper, cloth or a metal screen material is used to catch and trap dirt before it enters the engine. Now, in addition to cleaning the air, the intake system is usually designed to intake fresh air from as far away the engine as practically possible. So, usually just outside of the engine's building or enclosure we can do it. It also provides the engines with a supply of air that has been heated by the engine's own waste heat. So, this is the reason for ensuring that an engine's air supply is as cool as possible, because cool air is denser than the hot air. What does it mean? It means that per unit volume, cool air has more oxygen than the hot air. So, this cool air provides more oxygen per cylinder charge than less dense hot air. So, more oxygen means a better fuel combustion or an efficient fuel combustion, and if the fuel combustion is efficient, the power will be also more. So, these are the advantages of the cool air. After being filtered, this air is routed by the intake system into the engine's intake manifold or air box, and this manifold or air box is the component that directs the fresh air to each of the engine's intake valves or ports depending upon 2-stroke or 4-stroke engine. If this engine is turbocharged or supercharged, the fresh air will be compressed with a blower and possibly cooled before entering the intake manifold or air box. And the intake system also serves to reduce the airflow noise. Now, the exhaust system. As this system leads the engine exhaust, that is the gas which is going outside, either to the building, and it discharges it into the atmosphere. Generally, a silencer is also incorporated in the system so that the noise level should be reduced. So, generally in the exhaust system of a diesel engine, 3 functions are performed. First one is the exhaust system routes the spent combustion gases or flue gases that are available there away from the engine, where they are diluted by the atmosphere, and this keeps the area around the engine habitable. You could be there. Then second thing is the exhaust system confines and routes the gases to the turbocharger if we are using turbocharger in our power plant or DG set, etc. Then the third thing is this exhaust system allows mufflers, etc., so that the noise of the engine could be reduced. Now comes the cooling system. As the heat released by the combustion of fuel inside the engine cylinder is partially converted into work. So, some of the heat is there and the remaining part of the heat is passed through the cylinder wall, piston, rings, etc. And this may cause damage to the system also. So, to keep the temperature of the engine parts within the safe operating limits, generally we provide cooling. And the cooling system consists of a water source, pump and cooling towers. The pump circulates water through a cylinder and head jacket, and the water takes away heat from the engine and it becomes hot. The hot water is cooled by cooling towers and is recirculated for cooling again and again. As there are a lot of parts or components, piston ring, etc. So, we need a lubricating system also. This system minimizes the wear of rubbing surfaces of the engine. It comprises of lubricating oil tank, pump, filter and air cooler. Generally, the lubrication oil is drawn from the lubricating oil tank by the pump and then it is passed through filter to remove the impurities. Clean lubrication oil is delivered to the points whichever require lubrication. Points means to the parts or to the joints. So, the oil coolers incorporated in the system generally keep the temperature of the oil low. Generally, in internal combustion engine, it would not run for even a few minutes if the moving parts were allowed to make metal to metal contact. That's why lubrication is very important. Also, the heat generated due to the tremendous amount of friction would melt the metals and which would also lead to the destruction of the engine. And to prevent this, all moving parts ride on a thin film of oil that is pumped between all the moving components of the engine. So, generally this lubricating oil serves two purposes. First purpose is to lubricate the bearing surface and the other one is to cool the bearings by absorbing the friction generated heat. Generally, the flow of oil to the moving parts is accomplished by the engine's internal lubricating system. Oil is generally accumulated and stored in the engine's oil pan, where one or more oil pumps take suction and pump the oil through one or more oil filters. And the filters clean the oil and remove any metal that the oil has picked up due to wear or tear. This cleaned oil then flows up into the engine's oil galleries and a pressure relief valve maintains oil pressure in the galleries and returns oil to the oil pan upon high pressure. Generally, the oil galleries distribute the oil to all the bearing surfaces in the engine. Once the oil has cooled and lubricated the bearing surface, it flows out of the bearing and gravity flows back into the oil pan. In medium to large diesel engines, the oil is also cooled before being distributed into the block, and this is accomplished by either internal or external oil cooler. And the lubrication system also supplies oil to the engine's governor. Governor is there to regulate throttle and all. Then engine starting system, how we are going to start the engine. So, this is generally an arrangement to rotate the engine initially. Initial torque or momentum we have to give. So, while starting until firing starts and the unit runs with its own power. So, this is the arrangement for that particular time period. So, small sets are started manually. You might have seen in diesel generators there is a handle and we have to rotate that handle. But for the larger units, we use compressed air for starting. In this case, air at high pressure is admitted to a few of the cylinders, making them to act as reciprocating air motors to turn over the engine shaft. And once the engine shaft is turned over, it will start generating power. Once engine shaft will be turned over, fuel will be admitted to the remaining cylinders also, and it will make the engine to start under its own power. So, generally the compressor is used for this particular purpose. Now, the starting circuits. As diesel engines have many different types of starting circuits depending upon their type, size and manufacturers also. They can be started by air motors, electric motors, hydraulic motors and manually also. So, this start circuit can be simple manual start, push button, just we have seen in our cars etc., or a complex auto start circuit. But in almost all cases, the following events must occur for the starting engine to start. The start signal is sent to the starting motor, and the air, electric or hydraulic motor will engage the engine's flywheel, and then the starting motor will crank the engine. The starting motor will spin the engine at a high enough RPM to allow the engine's compression to ignite the fuel and start the engine running. The engine will then accelerate to an idle speed, and when the starter motor is overdriven by the running motor, it will disengage the flywheel. Because the diesel engine relies on compression heat to ignite the fuel, a cold engine can rob enough heat from the gases that the compressed air falls below the ignition temperature of the fuel. So, to help or overcome this condition, some engines have glow plugs. The heat added by the glow plug is generally sufficient to help ignite the fuel in the cold engine. Once the engine is running, the glow plugs are turned off and the heat of combustion is sufficient to heat the block and keep the engine running. So, larger engines usually heat the block and or have powerful starting motors that are able to spin the engine long enough to allow the compression heat to fire the engine. Now, the fuel injection system. It is an important system. This we are talking about the fuel injection system inside the engine. So, fuel injection system is a system for mixing fuel with air in an internal combustion engine. This system is designed and calibrated specifically for the type of fuel it will handle. In case of diesel engines, it is different. In case of petrol engine, it will be different. So, depending upon the fuel that we are going to use, it will be different. If you are using CNG or LPG, it will be different. So, most fuel injection systems are used for diesel applications which has the advent of electronic fuel injection. The diesel gasoline hardware becomes similar for this kind of system, electronic fuel injection system. So, here it is a programmable firmware which has permitted common hardware to be used with different fuels. Earlier carburetors were used, which were the predominant method used to meter fuel before the widespread use of fuel injection. So, variety of injection systems are available, are existing since the earliest uses of internal combustion engine. So, the primary difference between the carburetors and this fuel injection is that fuel injection atomizes the fuel by pumping it forcefully through a small nozzle under high pressure. While in case of carburetor, the pressure was low and it was created by intake air rushing through it to add the fuel to the air stream. The fuel injector is only a nozzle and a valve only. So, the power to inject this fuel comes from a pump or a pressure container which is further back in the fuel supply line. So, the major objective of this fuel injection system is same for all. However, some functional objectives may vary for different kind of fuel injection system. If we talk about the general fuel injection system, each and every fuel injection system share the central task of supplying fuel to the combustion process, and it is a design decision how a particular system will be optimized. So, there should be several competing objectives to make or to decide that which kind of design we are going to opt for. So, these competing objectives are power output, how much power is required, fuel efficiency, how much fuel will be consumed for the per unit power production, emissions performance, how much emissions we are going to get, we are getting higher NOx emission or carbon dioxide emission or carbon monoxide emission. Suppose carbon monoxide emission is more, that means the combustion is not proper. So, emission performance is also important. Then reliability, how reliable the process is, how reliable the fuel is, how reliable the components are there. Then the smooth operation. Suppose the combustion is not proper, then knocking will be there. So the smooth operation of the engine also depends upon the fuel injection system. Then the least but most important part is the initial cost. What is the cost that we are going to bear for this kind of injection system? So certain combination of these goals are conflicting, and it is generally impractical for a single engine control system to fully optimize all the criteria simultaneously. So generally we strive to best satisfy according to the customer's need competitively, or depending upon the power plant or kind of power we need or the efficiency we need. So generally the modern digital electronic fuel injection system is far more capable at optimizing these competing objectives consistently than a carburetor. So these carburetors have the potential to atomize fuel better. Now the process of determining the necessary amount of fuel and its delivery into the engine is known as fuel metering. Early injection systems used mechanical methods to measure or to meter this fuel, non-electronic or mechanical fuel injection system, but modern systems are all electronic and use an electronic solenoid to inject the fuel. And this electronic engine control unit calculates the mass of fuel which is required to be injected in the combustion chamber. These modern fuel injection systems generally have the similar setup. So there is a mass airflow sensor or manifold absolute pressure sensor at the intake, which is typically mounted either in the air tube feeding from the air filter box to the throttle body, or mounted directly to the throttle body itself. And this sensor does exactly what its name implies. It senses the mass of the air that flows over it, giving the computer an accurate idea of how much air is entering inside the engine. Next thing in the line is the throttle body. So this throttle body has a throttle position sensor which is mounted on it, typically on the butterfly valve of the throttle body. And this throttle position sensor reports to the computer the position of the throttle butterfly valve, which is used to calculate the load upon the engine. So the fuel system consists of a fuel pump typically mounted in tank, a fuel pressure regulator, fuel lines of either high strength plastic metal or reinforced rubber, a fuel rail that the injector connects to, and the fuel injectors. So there is a coolant temperature sensor also that reports the temperature of the engine, from which the engine uses to calculate the proper air fuel ratio which is required. So this fuel injector acts as the fuel dispensing nozzle, and it injects liquid fuel directly into the engine's air stream. In almost all cases, this requires an external pump, and the pump and injector are only two of several components in a complete fuel injection system. Now comes the performance testing of diesel engine power plant. So the performance of the diesel engine focuses on the power and efficiency, and the engine varies with parameters of the engine like piston speed, air fuel ratio, compression ratio, inlet air pressure and temperature. So generally two usual conditions under which internal combustion engines are operated are constant speed with variable load or variable speed with variable load. So load will be variable always, either constant speed or variable speed. First is indicated mean effective pressure. In order to determine the power developed by engine, the indicator diagram of engine should be available. And from the area of this indicator diagram, it is possible to find an average gas pressure which, while acting on piston throughout one stroke would account for the net work done, and this pressure is called as indicative mean effective pressure or IMEP. Then indicated horsepower. So the power corresponding to this indicated mean effective pressure is indicated horsepower, and it could be calculated as PM LAN divided by 4500 into K, where PM is indicated mean effective pressure in kg per centimeter square, L is length of strokes in meters, area A, that is piston area, in centimeter square, N is speed in rotation per minute, then small n is number of cylinders, and K here is 1 for 2-stroke engines and 2 for 4-stroke engines. So from here we can calculate indicated horsepower. Then brake horsepower. Brake horsepower is defined as the net power that is available at the crankshaft, and generally to measure it we measure the output torque with a dynamometer. So here it is brake horsepower is equal to 2 pi Nt divided by 4500, where N is again rotation per minute and T is the torque in kg meter. Then comes the frictional horsepower. Frictional horsepower is the horsepower that is lost. Indicated mean effective pressure is the indication of the power that should be available. Brake horsepower is the net power that we are getting. So frictional horsepower is the difference between the indicated horsepower and brake horsepower. So generally whatever is lost due to the friction is known as frictional horsepower, and it is utilized in overcoming frictional resistance of rotating and sliding parts of the engine. So frictional horsepower is equal to indicated horsepower minus brake horsepower. Then comes the indicated thermal efficiency. It is defined as the ratio of indicated work to the thermal input. Thermal input, why? Because here in case of engine we are giving, or the input, heat input is from the fuel only. So we know that the heat input will be weight of fuel multiplied by the calorific value of the fuel. So in denominator we have weight of fuel multiplied by calorific value of fuel, and at the numerator we have indicated horsepower. So it will be indicated thermal efficiency. For brake thermal efficiency, in the numerator we will be having brake horsepower, and in the denominator it is again same. Then comes the mechanical efficiency. So mechanical efficiency is the ratio of brake horsepower to the indicated horsepower, because indicated horsepower is the power that should be available there, and brake horsepower is the power that we are actually getting. So the actual power upon the power that was expected to be there. So it is the mechanical efficiency. Now let us summarize whatever we have learned. In this module we have learned the function of diesel power plants. The diesel engine drives alternator which converts mechanical energy into electrical energy. We have also studied the concept of fuel injection system and how it functions. We have learnt about inlet system, intake system, exhaust system, etc. also. We have learned that the diesel power plants are mainly utilized to generate small power output, which are mostly utilized as standby modes when power is not available. We have discussed that the use of diesel power plants is done for standby mode because the overall cost for this kind of engine is very high. Thank you very much.